let's get into the big topic of open source, something that we actually say at Red Hat.
We haven't
This is so
we
awesome.
are an open culture that believes
actually
in
a big
46.
piece
What is that process that a developer, or let's say
As the Kubernetes ecosystem really boomed.
Hello and welcome to this week's Ask an OpenShift Admin Office Hours live stream here on Red Hat Live Streaming. I am co-host Andrew Sullivan, joined as always by my other lovely co-host, Mr. Jonny Rickard. How are you, sir?
I'm good, man. I'm good. I'm here for now. We'll see how it goes, though. It's
here for now. You're not going anywhere, Johnny. You're not
hasn't
going
been
anywhere.
Good so far. I've been dropping in and out now.
That sounded very ominous, but I know what you mean. It's because your Wi-Fi is not very good.
It's really garbage.
You know, it's too bad you're not a technology guy or anything.
I know. I really have no excuse. This is actually pretty terrible. So,
how you been, sir?
I'm good, man. I busy. I think you know quite well what's going on. It's just been super busy around the company, and extremely busy for me.
Yeah, lots of Red Hat stuff going on all across the place. So coming up on gosh, is it already the end of quarter three? It is the end of quarter three.
It is, yeah.
So never a dull moment.
No, man. Got that Christmas hustle coming up, though, which is going to be a little fun.
We're well in pumpkin spice season at this point. I was at Costco the other day. They already have all their Christmas stuff out. So we just bypassed everything in between, July 4th and Christmas there.
Yeah.
So
at Home Depot, they have Christmas on one side and Halloween on the other. So it's like you have all the scary stuff, like looking down on the Christmas stuff. It's pretty funny.
Does that mean everything is Nightmare Before Christmas, themes?
Right, yeah. Whether they meant it or not, that's exactly what it is. Yeah.
Well, thank you everyone for joining us here on Red Hat Live Streaming. So this is a Office Hours live stream here on the channel. And Office Hours are designed for you all to ask us questions about anything and everything that happens to be on your mind. So Jonny and I are both OpenShift experts. We tend to focus on the things that are below the application level, lots of infrastructure-y type things. So we're happy to do our best to answer those questions for you. However, if we can't answer them, which, let's be honest, happens on a regular basis, we also have contacts. We have people that we can reach out to sort of all across the product and engineering and everywhere else inside of Red Hat to get those answers. So don't be afraid to ask anything that comes to your mind. Can't make any promises about developer stuff. Although today's guests, Ortwin and Stelios, are both pretty savvy on the developer side of things as well. Ortwin's pretty well known. Actually, dang, I should have worn my shirt today, Ortwin. The shirt that you sent to me. So sorry. So Ortwin is well known, certainly within Red Hat and amongst other places for Bobby Carr and a few other things. So very happy to have you all join us to talk about Red Hat Service Mesh today. Ortwin, Stelios, I will ask you all to introduce yourselves in that order, please.
Hello, everyone. And my actually second time here. And I'm really happy to be back again. I forgot how cool the intro is actually, and all the stuff around. So I think it's, what is it, episode 113, right?
113, yeah.
Okay, so I've prepared 113 slides for today, and
we anxiously await every one of them.
Yeah, it's not that much. No, yeah, I'm Ortwin Schneider, based in Germany, and I'm in the hybrid platforms business unit as well as you, Sully, and I'm really happy there to support the team and the product OpenShift in various ways, and primarily, building or creating solution patterns is one thing, and in general creating technical content and serverless, service mesh, and things around OpenShift, especially app dev related stuff is what I care most about, I would say.
Yeah, and so solution patterns there, which is slightly different than the validated patterns that Jonny works on. So solution patterns, we tend to focus on the art of the possible, as Chris Morgan likes to say. It's hey, look, here's some really cool things that you can do. And not necessarily something that has been done before, or has been implemented by a customer, but it's really cool stuff that you can do. Whereas validated patterns are sort of I would say the opposite, but there's still really cool stuff that you can do, but they're always customer adopted. And I think the great thing about validated patterns is, and this is Johnny's day job, everything about them is automated so that it can run through a CI system.
Yep.
So that every time OpenShift changes or GitOps changes or service mesh changes or whatever it is, it's run through that CI and validated. Hey, it's going to continue to work just like we said it did before the change.
Perfect. Yeah, great explanation.
Yeah, it keeps Johnny busy, so that's the important part.
That's right. Because I'm trouble if not, right? Like if I got idle hands, bad stuff happens. So.
What's that thing? Devil's playthings. Idle hands are the devil's playthings.
That's right. I'm living proof. So
I'm not touching that one. I'm just going to leave that be. Stelios, hello and welcome to the stream.
Yes, hello, and thanks for inviting me. This is my first time here in the Asking an Admin. I've been collaborating with Ortwin for the past year and a half around service mesh. My role is more on the consulting end, so I'm an architect in the app dev space, and have been in the app dev space all my professional life as far as I remember. So I'm more on the application side, and nowadays obviously try to understand how service mesh, also all the other cloud services technologies can be used as part of the application development in order to accelerate, but also enhance the capabilities that the teams have in their hands in order to implement their solutions in a more efficient way in the cloud. So that's what I've been working on, been focusing on. And hopefully we can pass on some of that experience to the audience today.
Yeah, and I may be spoiling the headline here, but you all also published I want to say, cookbook for service mesh.
Well, yeah, it started like a handbook. It didn't quite reach the cookbook, although there's so much topics that we can talk about. So it's myself and Ortwin last year got together and decided to go a little bit beyond what you can find on the product documentation or even the project documentation, and kind of look at it more from how would I start if I knew almost nothing about service mesh, making decisions and heading to production with these decisions. So from day one operations to day 2 operations all the way.
Yeah. Yeah. And is that, I feel like I should know this. Is that an ebook, or can you actually get a print copy of that?
It is an ebook.
Okay.
We didn't get a printed version of it, mainly I think due to not seeing people due to COVID.
Yeah.
But yes, it's an ebook, and I think there is on the slides that Ortwin will share is a link that we can share also on the chat for people to get, because it's free.
Great. Well, that's awesome. I remember Ortwin telling me about it being published, and that's super, super awesome. And I'm very happy for y'all. And I know I have scrolled through it. I don't understand most of it because service mesh is a little, I'll say it's a little beyond my normal thing. So I don't have a lot of hands-on experience with it. So I'm very much looking forward to this session and learning more about it. And I especially like the in production aspect. There's a lot of things that, as I said before, right? The difference between a solution pattern and a validated pattern, right? Hey, look, this is really cool. This is something that I can do. Like, well, what does that actually mean? Like, what are the long-term implications? And, how do I manage and maintain these things? So Johnny, let's switch over to top of mind topics here real quick and cover the couple of things that we got on the agenda.
All right, right on. Yeah, so the very first one is just a reminder to everyone that OpenShift 4.14 is going to be releasing soon. I'm not exactly sure on the date. I think it's end of October or something like that, but everything could slide. And so just take a look at I'll post an article here shortly, but take a look at the link and make sure that nothing that you've got running is going to be affected by the deprecations. And then the OpenShift 4.14 What's New session is going to be October 12th at 10 a.m. Eastern. So if you want to find out what's coming up in OpenShift 4.14 and kind of beyond too, come check that out. Andrew and I are usually there in the background answering questions.
Yep. Yep, I'll be there helping answer questions, shuttle questions between what we do on the live stream here over to the PMs and stuff like that. So please do come out, listen to us, find out what's happening in 4.14. There's a ton of improvements, ton of changes that are happening there. So I always find those to be very informational. And of course, Jonny and I will have a series of streams afterwards, although probably not until November, just because of our calendar, right?
Yeah.
So the month of October is going to be DevSecOps month. So we've got 4 topics in there leading up into KubeCon the first week of November. So we will not be streaming the week of KubeCon. And then we've got a couple other things that we've got baking in the background. The ACM folks are going to be coming on in late November. We'll be talking about 4.14. And Dwayne, I see your question there. So Ortwin has a link to it in the slides that we'll look at in just a moment. And as always, we'll share the slides out through SpeakerDeck after the stream. What else was I going to say? I don't remember.
Well, I just want to add one thing about the what's new stuff. If you're watching that video, like live or otherwise, if there's something that you see that you want us to talk about, reach out to Andrew and I, and we'll try and make that a priority. Whether we just cover it briefly, or we do like a quick demo on it, or we do a whole session, just let us know, because we definitely want that feedback.
Yeah, absolutely. We always love requests and suggestions. Oh, that's going to bug me now that I don't remember what I was going to ask you or talk about. It must not have been important.
It'll come back to you.
It'll come back to me. Here in 45 minutes, I'll be like, aha, and
I remember now.
interrupt Ortwin or Stelios. All right. So I think that was really all we had. Just a reminder. So with every minor release of OpenShift, so 4.12, 4.13, 4.14, the .12, .13, .14 is the minor release. Remember, the day that it GAs it is fully supported and fully available to customers, but the upgrade path won't necessarily be in the stable channel. So the upgrade path usually on release day is in the fast channel. It is fully supported, but it usually takes somewhere between 45 and 60 days for it to be promoted into stable. So that's normal. Sometimes it takes longer. Rarely does it take shorter to be promoted to stable, because they go through and they do a lot of validation and a lot of, as errors and issues get reported, as more people adopt it, after release and all that. So just keep that in mind. I don't know, Jonny, do you know off the top of your head whether or not there is any SEC changes like there have been the last few releases? I don't know.
I don't believe so. Yeah, I think the biggest one that stood out was the storage was going from like V1 beta 1 to V1, I think is what it was. So that seemed to be the biggest one.
Yeah, I know. I think it was 4.12 had the SEC V2 changes and stuff like that, or maybe that was 4.13. One of those had some significant changes that I know have caused some consternation with upgrades. But
nothing major this time. I think like that.
Yep. Yeah, and 4.14 is an EUS release, so the typical accelerated update or upgrade path rather will be available. So we'll talk about all that in more details once we get closer to that time. All right. Well, we've rambled, we've delayed, we've put off long enough. Let's talk about service mesh. So, Ortwin, Stelios, as I said before, my knowledge of service mesh, and when I say service mesh, I'm referring to this sort of umbrella term of, OpenShift service mesh is relatively limited, right? I know that we have Istio in there. I know we have Jaeger, right? There's some other components. But aside from, I know we can use it for things like distributed tracing. I know we can control traffic flows and stuff like that. I don't know a whole lot about it. So if you wouldn't mind, can you give the dumb guy's overview, and dumb guy I'm referring to as me, of service mesh? What is service mesh? Why do I care about service mesh? When should I use service mesh? And we can kind of go from there.
Sure. Yeah, I actually have some slides, some I would say introductory slides, which should partly at least answer the things you've asked. So what is service mesh in general, and kind of the core capabilities and use cases, why should I use it? And then we could, move to like, if you consider introducing service mesh in your company and it tends to be quite complex if you really use it in reality, right? And there is a bunch to consider. So there are different aspects you could or you should gather at the beginning before implementing it. And we walk from there, like with this fictive use case. This is what we've also done in this ebook, kind of. We've said, like, we have this company and they have some requirements, they have an application running, and they're considering introducing service mesh. So now, what does it mean? What are the requirements? How can we fulfill them? We need a development environment, we need a production environment, we have some partners we want to integrate later on. So there are some use cases, and they kind of depend on each other. So we start kind of building from a dev environment to a prod environment, and up to day 2 operations, right? So this is kind of also what we want to talk today. I have some slides, as I've mentioned, not 113, but a little bit less. So let me just share my screen, and we could just start with what service mesh is. So you should be able to see my screen. Is that right?
That looks good.
Okay, perfect. So yeah, actually the title is Heading to Production with Red Hat OpenShift Service Mesh. So this is more or less the main topic or the main focus for today. So we want to consider some of the aspects, of course not all in detail. I mean, there is the good thing is you have this book, and you can also do everything you see also later in the demo. You can go through all the lab sections yourself. We have it internally for Red Hatters, in our demo platform, but there is also kind of an upstream version where everyone outside, if you want to try it and walk through the things we show you today, you can do that as well. So so we skipped this. You already know who we are. So basically for today, as mentioned, so what is service mesh, capabilities? The ebook was mentioned already, and then the main thing is like introducing service mesh, or all the heading to production topics. We have a live demo prepared where we show some of the aspects also from the book, and then we have some day 2 operation topics like tuning and troubleshooting, and also interesting kind of the current service mesh roadmap. So what's coming next in OpenShift service mesh, like with service mesh version 3, a lot of things will change, for example. And there, here and there, questions arise, like what is with ambient mesh and things like this. So this is basically what we've prepared for today. Here's the link as well. I think you have it in the chat already. So this is the ebook. You can just go there, click the link, and click on download, and I think it's even not necessary to sign up or something, so you can just download this little ebook. Exactly, what's in the ebook? All the things I've already mentioned. We have this travel agency company, and we have all these different use cases. We walk with this company together through and create all the necessary, service mesh artifacts and so on. I won't dig deeper into this right now. Let us start with, for especially for people who don't know really what service mesh is. Basically, you could probably in one sentence say it is kind of a programmable network. So we have a bunch of microservices, and we add some user space proxies as sidecars next to our services, and they kind of intercept the traffic coming to services and going out to services, and they do something with them. So you can modify the traffic on kind of layers 4, layer 7, and there's a control plane that manages all these proxies. So there's a central place to manage this, and you have a bunch of APIs for this control plane. And proxies are layer 7 aware. This is where the real power is actually, and they can act as proxy or reverse proxy. Actually, in OpenShift service mesh, so we talk about envoys.
Ortwin, can I ask you a kind of basic, maybe even silly question?
Sure.
Service mesh in some ways kind of feels like an SDN, right? Because I'm able to direct traffic, I'm connecting different pods together, but it is not in and of itself an SDN. It's not a replacement for an SDN.
No, it is not. It is not. It's not only about let's say the pure networking aspects. It's also, I'm not sure what you if SDNs are what's possible on layer 7, for example, right? So it is way more than just a pure networking solution.
Yeah. So, because I think, and I'm trying to think, this is me thinking off the cuff. So, apologies for any rough analogies. So, there's effectively, with service mesh, there's effectively 3 layers, right? So, there's the base physical networking layer that each one of the OpenShift nodes is connected to. And then there is some sort of SDN. With OpenShift these days, the default is OVN Kubernetes, that creates a logical network that connects all of the different nodes together, right? And this is where pods actually do their communication.
Yeah.
Service mesh is for application level traffic, right? Pod to pod communication that has additional functionality layered on top of it. The SDN is typically just providing connectivity between those pods, so that way they can, leverage a service or a route or something like that. But service mesh is much more than that.
Yeah, it's kind of also leveraging, I would say, the existing SDN, right? So the Envoy proxy, it is also a container like the actual application container you have. It uses the same, SDN components and features. And the one of the Istio components, which is the Istio CNI. So this one is modifying kind of the IP tables, which is then intercepting, the actual traffic and is sending it to Envoy, and is doing all these, let's say, networking magic in behind, right? But it's kind of the envoys, the proxies themselves, they're using the same thing. So they use the same SDN like the rest of the cluster.
Yeah. And Hasifas, is service mesh a replacement for or an alternative to maybe standard network policies in Kubernetes? And I think the answer to that is no, but they can offer similar functionality.
Right. It's complementary, I would say. Yeah.
Yeah.
So both together is perfect to actually implement something like a 100%, zero trust environment. So you need both. And by default, for example, Service Mesh also uses Kube network policies for namespace isolation and other different isolation things. But it's definitely not a replacement. It's something additional, and it's complementary, definitely.
Got it. Thank you.
Okay. Yeah, cool. So the basic, very high-level service mesh architecture, and I'm looking at the the OpenShift architecture, and we use Istio, right? So Istio is the core upstream project. So we have productized Istio as well as some other additional projects like Jaeger, Kiali, and so on. They are all part of the current offering of our OpenShift service mesh. And basically, we have two things. There is Istio-D, which is kind of the core control plane component. It's implemented currently in one process, and it offers a bunch of APIs. It does certificate management, service discovery, all the configuration for the Envoy. So everything happens from this control plane. So all the configuration, they will be translated into Envoy configurations and will be distributed to the sidecars, right? And as mentioned, there is the Istio CNI, and this one will kind of modify all the IP tables and redirect the actual traffic to the envoys. And there we can now do what we need to do, modify, route traffic based on certain conditions, do rate limiting, do all these fancy stuff Envoy gives us, right? So this is kind of how it works. This is a standard sidecar model. So this is what we have as the standard environment. And additionally, in OpenShift Service Mesh, we have some other things, for example, for distributed tracing. So the Envoy proxies, they will also create things like metrics. They create things like new traces or spans. So from a software developer perspective, if you want to have distributed tracing, you have to just propagate the existing headers, as you work with them, and then you can have distributed tracing with Jaeger. So Jaeger is also part of it. Kiali is a nice visualization for OpenShift Service Mesh. We will see some of the parts later also in the demo.
Sorry, Erwin. Can you do like a 30 seconds of what is distributed tracing? Like what does that mean? How is it?
Yeah, in general, like what you see here on the screen, we have 3 services, right? There is service A, B, C, and when we send a request to service A and this calls service B and calls service C and D and whatever, and if you have a bunch of microservices and they call each other, there is kind of a request path that could involve, you know, different services. And if something goes wrong at some point, or there's a latency, or you know, it's really hard to debug and to troubleshoot and to, you know, make it visible where the actual problem is, identify the bottlenecks, things like this, right? And this is where you actually use distributed tracing, which means you will create a new trace. So for every request, we create a new trace, and each request step in this complete chain will get an own span. So this is kind of a sub request, so to say, right? And we add them. And the way it works by populating certain headers in our requests and responses, you know, this way we can identify that this request from service B to service C belongs to the origin of this complete request. So in this chain, you know, and we can make this visible, and we can see then, okay, this service did call this service, and this is the latency, there was an error, and so on, right? So we can trace requests which are pretty, you know, complex and in a long request chain. Did it help a bit, or I mean?
Yeah, I'm. So effectively, when we say event, right? So, like you said, the microservice A, it issues some sort of call, right? Some sort of transaction against microservice B, and because that is proxied through the service mesh components, that gets recorded both when it initiates and when it lands. And so we're just recording all of those events into. Now I forget the name of the component. Jaeger, right? So Jaeger is capturing all of those events as they're happening, and then we use Kiali to be able to go back and look and say, okay, my application transaction, whatever that means, you know, it required or it did all of these microservices, and I can follow that through and see, oh, this transaction, microservice, you know, echo took 47 seconds in order to complete whatever it was doing, and that's why there's so much latency in the application. And then from there you can kind of dig in. So that's why the distributed tracing thing is important, because it gives, from an application perspective, not necessarily from a developer perspective, but whoever is managing that application, it gives them visibility into both how traffic is flowing, but also oftentimes the health of that traffic as well.
Perfect.
And if I can add to that, so you're correct that Jaeger will actually store it, but it's actually the sidecar that will capture it, and by default, without having to instrument your application layer with anything, it will capture traces for the communication, like you said, between the microservices that are part of the service mesh. But then you can enhance that, because I think developers already do instrument the microservices for traceability, but you can combine it as well. So it could be that like you said, the delay is between microservices, but it could be even within the application code. And where exactly is that? So the developer can actually further enhance and utilize the same components that the service mesh offers to further enhance that traceability. But by default, out of the box, at least the network traceability and the latency in that network traceability, or the errors, can be identified out of the box.
Got it.
Yeah, so you have both, right? You have kind of the tracing in Envoy and the things that could go wrong between Envoy, but you can also, as mentioned, instrument your application as well. And you send kind of the spans to the collector, and this will feed it into the database, and later on you can visualize the things.
Yeah, and so Omar asked a question here about an alternative to service mesh, or is an alternative to service mesh the use of Quicksec? So I'm not familiar with that. I just did a quick search on it a minute ago. So I don't know if either one of you are familiar with it.
I'm not very familiar with it. I think it's an HTTP3 thing. So I believe that within the service mesh, you have effectively the same capabilities, but you need to be part of that mesh, right? You need to be part of the same mesh in order to maintain these capabilities of exchange of certificates for MTLS purposes. But I'm not 100% familiar with how Quicksec would actually materialize that. So yes, to an extent, within the mesh, for crossing the boundaries of the mesh, I'm not sure it works the same as it would for
Okay.
Quicksec.
Thank you, because that was a wholly new one to me. So Ortwin, I'll hand over to you.
Yeah. Okay, we are here, architecture, and the way you manage the different components are basically, we have an operator. This is also the standard way you install OpenShift service mesh. So there is one service mesh operator, and then you also use the existing, Elasticsearch or Jaeger operator. So you install kind of 4 operators, and then you basically work with custom resources. So for installing the control plane and configuring the control plane, you use currently a service mesh control plane CRD. So it is the SMCP abbreviated. This is as of now. And then for configuring, the Envoy proxies, you use also standard Kubernetes custom resources, or Istio, better say Istio custom resources, like, for example, here, gateway, virtual services, destination rules, and the different authorization policies, things like this. So this way, you basically configure your mesh and the control plane. Yeah, so we already talked about this, the service-to-service communication within the mesh is through the Envoy proxies. They form kind of the the data plane of the mesh, and then we have for external interfacing external services, we have ingress and egress gateways. If you want to, for example, if you have a web application, you want to let traffic outside of the mesh inside the mesh, you will use an ingress gateway and combine it with a virtual service and destination rule and configure kind of the ingress into your mesh. And you can do the same thing with egress gateways. Both things are more or less standalone envoys, so they're not sidecars, they're just standalone envoys. And you can also have multiple ingresses, and also, in different namespaces, you can deploy it alongside with your applications, and there are different, let's say, topologies, how you could set them up. You can also combine it with OpenShift routes. And for example, if you create a new gateway, it will create also an OpenShift route that makes it really available from the networking perspective. Yeah, so this is basically the connecting side.
Just sorry, just one clarification, or if I can add to this, if you go back to the previous slide, there was a question about if it's an alternative to network policies. So exactly at this point, it's useful to know that effectively the effect of the service mesh for anything that is part of the mesh is to be isolated from anything outside, like the policies would isolate one namespace to another. And for the purpose of doing that, it is actually using network policies. It is applying network policies in the background. And so as an effect of that, you need an ingress or an egress gateway in order to access what's inside the mesh, unless, of course, you relax the default network policies. So at least, hopefully, that's a bit clearer for the people that they didn't know how this gets implemented. It is using network policies, and it is using the ingress and egress in order to bypass that and allow traffic into the
Yeah, right.
And when I have a question, and then there's a question from the audience. I'll ask their question first. So rhope9 had asked, can the egress gateways use the egress IP? You know how so if you configure an egress IP, would the egress gateway be able to consume that and use it?
As far as I know, it is possible, yes.
Okay. And then my question is more of a kind of like implementation, like, I guess not really implementation, but when you're thinking of a big picture, what's the overhead of running service mesh with the multiple Envoy proxies and stuff like that. So, like, is there a calculated hit that you're going to take, or is it so minimal that we don't really care? Like, do you have like some of those numbers?
There is definitely an overhead, of course. There is also, especially in larger service meshes, you have to take care also on the Envoy proxy configuration sizes as well. And because in general, all the things you configure, they will be distributed. So all the different routing tables and everything, right, will be distributed to all Envoy proxies, even though the sidecar will never access a specific services or things like this, right? But by default, they will be distributed to everyone, so they can really raise in memory and things like this. So we have to take care a little bit about things like that. And the overhead, I'm not sure Istio published something around it. And also we have something in documentation. I'm looking at it. As far as I know, it is like a 10% overhead that you should calculate when using service mesh.
Okay.
And there's a question here from Gustavo. What is the foundation enabling service mesh? And then asking if it's similar to Quicksec, which again I don't think we're familiar with.
So I think Ortwin is going to talk about a number of use cases. So when I read the word foundation, it comes to mind that there is one thing in place. Service mesh, Red Hat OpenShift Service Mesh is a productization of the Istio project, and effectively there's a few use cases that the Istio covers. One part is the networking, another part is the security, the observability. So there's not a single foundation that you start from, but as a project, we basically use the Istio as the foundation of what the service mesh will offer. But it's not for a single purpose, and you don't need to use it for all the purposes that it's there for. That's the other message I think that people should be aware of. We've seen customers that they want to use it for applying standards of security to all the microservices. We've seen other teams that they want to use it purely for the observability, and we've seen teams that they want to use it for a combination of purposes. So the main aim is to extract capabilities that you want to have without having to re-implement them in every microservice or need to provide it as part of every platform, but have it out of the box as part of the service mesh. That would be more or less my answer to this question, if I understood what foundation means in this. All right, maybe you can go with these use cases.
Yeah, so just one thing, I've already mentioned it. This is our, OpenShift kind of cake diagram where we have like our product portfolio in terms of OpenShift, and you see the service mesh is part of the platform services here. It's one of the layered products like serverless or CI/CD pipelines, GitOps, and you can install it, as mentioned, with an operator. No additional costs. If you have a container platform subscription, it is kind of enterprise ready and available for you. Some capabilities and use cases, and also in general, who uses service mesh and why. So we have later on also a section in terms of personas that we typically identify, but in general, and this really reflects what we see in reality is that most of the time, the people who actually maintain, operate, and configure a service mesh are actually platform engineers, or let's say more admin people. And basically people who, operate application environments and care about them. So they do they configure the application behavior. They enforce, for example, MTLS encryption. They use other security features. They configure resiliency for the applications, and especially for networking related stuff. They can also configure traffic management and A/B testing, usually things that they work together with actual developers are more or less for resiliency feature, because in the past you usually it was the actual developer who implemented resiliency features, right? And now we shifted this this topic completely to this infrastructure layer, to service mesh. So basically, the way developers use it, they use service mesh by kind of not using it at all, more or less, right? So they can really focus on the business logic. They don't have to care about certificates and encryption and retry logics and implementing some kind of circuit breaker and all of that stuff, which they had to do in the past or without using service mesh. So they can really focus on business logic, and we can configure this one with a central interface, in this infrastructure layer. So this is kind of what we also see in reality. Stelios, from your experience, you're the one in the field, you're implementing, or you had a lot of customers where you've implemented service mesh. What do you say? Who is kind of the party really working with the service mesh artifacts like virtual services and all that stuff?
Yeah. So yeah, I agree that platform engineers are the main parties that they use that. The other side of usage, depending on the environment. So if we're talking about development environment, we see quite often the application teams using some components of it, especially the observability stack. But also, depending on the customer, depending on what other tools are available, we also do see the product owners as well. Because part of the observability can give you information about the usage, the healthiness. So we also see these type of uses. In the interest of delivering, obviously, a solution on top of the service mesh, we do have the application teams involved. But depending on the organizational structure, they may implement their own data plane configurations, or they may rely on the platform engineers to implement them for them or with them. But yeah, platform engineers is the correct persona and within the organization.
Okay. Yeah. So then coming to the more or less 4 core capabilities. So one thing we've already talked about is securing services and security in general. So it's very easy with, for example, service mesh to enforce MTLS encryption across all services. It's a little YAML file, and you can really enforce this in the complete environment, for example. Then so each service also gets an ID, and then we can, for example, configure authentication and authorization policies. So who's allowed to talk with which service, from service to service or user to service calls. So this way we can really, in addition with Kubernetes network policies, we can really do something like a zero trust networking. So this is really powerful, and this is, I would say, in reality also the #1 use case why people use it, because this typically without service mesh can be quite complex to set up, especially if you have a lot of services. You can quite easily set things up here. So Istio also, generates certificates and does end-to-end encryption at scale. So as mentioned, each workload has a unique ID, and it automatically creates certificates, distributes them to the Envoy proxies, and they are also rotated. You can also integrate, this is GA right now, you can integrate with your corporate issuers like HashiCorp, Vault. So Cert Manager is also GA in this context. And the other use case or main thing.
Just one thing, Ortwin, if I just interrupt there, just to emphasize something that you said earlier. You can apply authorization policies, which is an enhancement to what OpenShift offers. You can't stop in any way in OpenShift services, microservices within the same namespace or across namespaces to talk to each other. And with the service mesh, you can apply out of the box a deny all policy without doing much more, just based on, like you said, the identity that they get. Obviously, the default one is allow all, but you can deny all, and that means you can from day one enforce people to think about really which microservice needs to talk with which microservice, and that's one small configuration which you might have OpenShift, but you wouldn't have that without the service. You need to apply that with other techniques. So that's one benefit, that it helps the teams to think from day one on which other components they really need to talk to, which other namespace they need to talk to, and apply that from day one.
Right.
And Dwayne also asked a question here of can service mesh assist with zero trust on the far edge?
We're working on understanding that. Yeah. If I'm honest, this is something that we are considering as a use case for the service mesh from an implementation, from a delivery perspective from my side. But I think we need some other components that will help us to like Scupper, to combine with this. We have in labs ourselves as a delivery team employed and created proof of concepts around this, but we have yet to see that on the edge. But it is a use case that we're working on, and when we have more, maybe we'll come back and we'll talk about it.
If I'm reading between the lines here, so the problem is the expectation is for a far edge device or endpoint to be not a part of the same cluster. So typically the service mesh would not extend outside of the cluster or incorporate other clusters inside of it without something like Scupper to act as that connection point between each one of them. Got it. So short term, probably not. Long term, maybe.
It is something that we are considering, we're looking into, because then it would actually allow you to centralize the management and the policies with service mesh and incorporate these far edge devices to your mesh.
Got it. Thank you.
Yeah, and that's a big story you're tying together too. Once you get that right, I mean, like that's awesome. Yeah.
Oh, hey Johnny, I just remembered the other thing that I was going to bring up and talk about in top of mind. The Magic Quadrant result for OpenShift. Did you see? I don't know. Sorry, completely tangential. But they announced the Magic Quadrant for container management platforms, and OpenShift Red Hat was declared a leader. So, anyways, I don't know what made me think of that very randomly. Here we are. What did I say? 45 minutes later. Well, it's been 35 minutes later. Anyways, sorry to interrupt.
That was very important. Yeah, okay, cool. The other thing was monitoring, observing. One of the other capabilities also, as mentioned, we have the proxies in place, and so they can give us full visibility of all the traffic running through or flowing through the proxies. So we have metrics where we can see like the request volumes, failure rates, all of that. Then we have distributed tracing to identify bottlenecks. And we have the additional products and tooling around it, which is bundled currently with OpenShift Service Mesh, and we will see this also later. Just this use case alone, if you have an application with a bunch of microservices, it might be worth to just use Service Mesh for observability, that you get really insights and you see what's happening between all these services. So this is also a great use case for it. Then, of course, as mentioned, implementing resiliency for your microservices by doing things like a circuit breaker, configuring timeouts or retries in terms of network failures, for example. And you can also do a little bit of fault injection, like chaos engineering, so you can configure your kind of errors. You can say like, okay, and 50% of the requests should fail with this error code and things like this. So you can test your services and how the complete system react on it. And you can do it in production like other companies do, or you can just test it in your environment. But the main thing here is all these features you can do it without source code changes. And this is the real benefit, because that was something that you usually had to implement in your microservice, and you had to implement different libraries, maintain them, and things like this. And now you have just service mesh, and you can configure things centrally. So resiliency, one thing. And then in terms of releasing services, all the traffic flow and traffic management, you can do a bunch of different deployment topologies or types, like canary deployments, A/B testing. You can mirror traffic also. For example, from your production environment, you can mirror traffic even in a different cluster. You can federate also different service meshes in different clusters and export services, things like this. Mirroring traffic, testing your new services against live traffic. All these routing and traffic manage capabilities. So these are basically the four main capabilities of a service mesh, not only OpenShift service mesh in general. Yeah.
And on this front about the releasing services and all these features, this can be quite nicely combined with Argo rollouts. And this also been a part of, I think, GA as well. It's very nicely tied together. So if people are familiar with Argo rollouts, this part of the features that the service mesh offers, even if you didn't use all the other ones, would be an interesting thing to try out. And there is a link of a workshop around this. I'm going to try and find this and share it with Sully so he can put it.
Jonny picked a bad time to duck out to do whatever he's doing, because Argo and rollouts that's his thing. So
okay,
I'm back. I'm sorry. People were showing up to my house at the same time on the side, or at different times. I have to go and deal with it. I was actually going to ask you about the rollouts because this is where I think this is where two products could intersect and do some really awesome magic, right? Because the rollouts do the canary and I'm going to kill the dog. But they do the rollouts, and they also do the canary test, or the A/B testing and the canary deployments and stuff like that. So, it's kind of cool. I think there's a limitation right now with routes and in the integration with rollouts, just because it's still fairly new. But I'm excited to see it happen, and to see that you can actually do it in a completely different platform and hopefully have the same effect. It's pretty awesome.
Yeah.
Okay. So we spent the first hour for introducing what service mesh is, and
remember, I told you, expect everything to take twice as long as it normally does.
Yeah, no, that's absolutely fine. So now we come to the real content, and basically that was really a little bit just introduction and core capabilities, and now we start a little bit with thinking about how to introduce service mesh in your company if you consider using it, if you think these are great capabilities and it would make sense. What topics should I care about? And here we can start with discovering, navigating the service mesh needs. So Stelios, I just hand it over to you. And
so we could spend I think another day on just this diagram, which is not very visible from what I see, hopefully by sharing this. In order not to spend all the remaining time, I just wanted to highlight that because of the complexity and because obviously of the different use cases, it is difficult to identify easily what do I need to capture, what requirements do I need to capture. And one thing obviously to take into consideration is that some of these capabilities that we talked about, they're already part of either the application component, the development team has integrated them in the application components, or they are part of the platform. So we already have kind of the requirements that we are asking of service mesh. We just need to understand what are the features that we need implemented, as I said, as part of applications or part of the and then look at maybe this atlas to identify more focused areas of capturing requirements. So in summary, and I'm not going to go into much detail, is the deployment model. So how we deploy the service mesh, and that gets affected by the OpenShift type clusters that we deploy. I'll talk about it in the next slide a little bit about that. the tenancy models. So will we have effectively a single service mesh in our cluster, multiple, and who are the stakeholders and what are the responsibilities for managing? So this is around the governance of the service mesh. So we need to capture requirements about that. The non-functional requirements of the service mesh. Obviously, we are running the service mesh in order to support a data plane of microservices offering a solution, either a streaming service or just a normal service, and we just need to cater for the performance from a control plane in order to support the data plane. So we need to capture what are these requirements, like I think Jonny asked earlier about latency, throughput, and the likes. Then obviously the observability, there may be tools already in place. The development teams might need to have additional tools in order for them to during testing and functional testing, understand the healthiness of the application. There may be tools that we need to integrate with. So we need to capture requirements about what's not there or what's there and what we need to integrate with. And of course, security, always a big topic in order to understand what are corporate standards and how we can implement and comply with them with service mesh, and also what are security authentication authorization standards that we need to assist. So capturing all these requirements, and this atlas is for that purpose, to give us guidance about the areas, will be the first step before you introduce anything, before even deciding that you can and want to introduce service mesh into your applications or into your clusters. And with that, if you don't mind going to the next slide, unless there's any questions that I didn't see in the chat, the two main areas then I want to emphasize in order to bring service mesh into your clusters is defining the service mesh deployment model. And when we talk about deployment model, as I said earlier, service mesh offers the capability of isolation natively. That means anything that is part of the service mesh, and not everything in an OpenShift cluster needs to be part of the service mesh, will be isolated from anything external to it. So we need to understand that. And also we need to equally understand what other types of isolation are in place without the service mesh. So for instance, maybe the solution is split over multiple clusters, or there is a different hosted network definition. When we understand that, then we look at, is the OpenShift cluster that will deploy the service mesh and configure and maintain it a dedicated cluster? That means we have a single solution or solutions from a single business unit, or is it a domain, a multi-domain cluster type where we have a very big cluster with many business units in a multi-tenancy way deploying their solutions on it? And with that, then we can start envisioning also what is the deployment model of the service mesh. So in the first case, the dedicated cluster might consider a single control plane managing all the microservices inside the cluster and being part of the same service mesh, since there will be a single business unit, a single architect defining the same networking and security standards. Whilst in a multi-domain cluster, we might consider to have a single control plane, or there's a Red Hat OpenShift service mesh feature of multi-tenancy where we can have side-by-side the control planes for the different business units, isolating the client applications within the same cluster from each other. This is on the network level, isolating them. And there can be many reasons for deciding one over the other. There's no one solution answer for everything. For instance, we identified some time ago that having a single control plane, although it was easy from management perspective, for configuration management perspective, it was causing an issue when there was a very large set of microservices pods. I think we was kind of somewhere 500 plus we found. That was causing an issue on the ECD service of the control plane. Now this was fixed on the latter version of the product, but then again, having such a large single mesh meant that every configuration, like Ortwin said, from every sidecar, that is basically your entry and exit point from the mesh, had to share with all the other microservices. We're talking about 500, 1,000, whatever it is, 10,000 in your cluster. That was creating a very bloated sidecar, sometimes actually requiring more memory than the business workload. So again, going back to having multi-tenancy with multiple control planes would solve this, because you have a much more dedicated control plane, much more dedicated isolation through that deployment model for your microservices. But again, you bear the cost of having multiple control planes. So there's different ways, and because the service mesh is trying to offer deployment models to cater for the different use cases. And once you understand what the architectural principles, you identify them, then you can define which deployment model is more appropriate for your cluster, for your solution. And then you can click to the next.
Also to add here, Stelios, also, if you have like one control plane and you have really a lot of namespaces or domains that are managed there, this creates actually also a bunch of API traffic load on the Cube side, right? So you have to take care, and it's good to know what kind of structure type your application is, and also to then kind of decide for the right service mesh topology.
Right, exactly. And the other area of focus when bringing a service mesh implementation to your solution and to your cluster is the mesh model of operation. This term we use to determine effectively who is involved in the configuration, deployment, and maintenance of a service mesh. And you think that's quite easy. We mentioned the platform engineering earlier, but it's not always as simple as that, because maybe they're the ones implementing some of the configurations. But since the service mesh is not deployed for a pure platform concern, and it cannot be agnostic of what you will deploy on it. So we need to get advice from the application side on what that is. And the problem is it gets exacerbated when you consider the different roles that can be involved. Let's say the platform admins, the DevSecOps teams, or the dev teams. We need to take input from all of them. So the conclusion is that effectively we can look at maybe 4 aspects in order to understand for that specific service mesh, what is the mesh model of operation. So what is the cluster type, like I mentioned, dedicated or multi-domain, the type of automation, also the operating model. So is this service mesh going to be operated in a self-service manner? So some teams actually operate the whole service mesh and the data plane as well as the control plane themselves, or is it going to be operated in a producer-consumer fashion where you have maybe the platform admin team doing some of the work on the control plane and the data plane team consuming networking, security, observability from that, and applying the defining effectively network connectivity, authorization, and the likes in the data plane side. And finally, if there's a DevSecOps culture, these kind of characteristics then gives us an indication of what we are delivering the service mesh for, and then it can then help us to understand the roles and responsibilities for the corporate personas, so that we can apply them in that cluster and have them consume them so they can do their job. Now here, and if you can click until yes, so that basically is a couple of examples from a specific customer who had 2 use cases of 2 different clusters, and we ended up with 2 models of operation. A multi-domain cluster where basically we applied the producer-consumer model. There would be a platform admin team, and they would be responsible for delivering the configurations in the cluster for the control plane, for the secrets, mentioned MTLS, and for the certificates that contain the secrets, basically, and also for the ingress packet. Whilst the DevSecOps team was responsible for networking, A/B testing, and the likes in the data plane. And then there was another model, the dedicated cluster type, where basically the team, the DevSecOps team, was responsible both for the control plane and the data plane. And that was a model that, the model of operation that resulted in having different permissions for the 2 teams depending on the cluster that they operated in. If you click on the next slide. And the final thing I want to say about this is effectively you need to come to the conclusion also what are the personas that operate the mesh. This is a list of the most common ones we see in every organization. Now, when we say personas, maybe a real person combines a persona in your organization. But as roles, we usually find them available to work with or work on the service mesh in most of the organizations. I'm not going to go through it. You can read that from the slides in the interest of time later on.
It reminds me of ITIL and how there's all of the different hats, and some people can wear multiple hats.
Yeah, you can. And the reality is, as I said, there's no one organizational structure. You just need to identify and understand it, because the problem is Istio, and by extension Service Mesh, does not define standard or default roles about this. And so every project team needs to understand and implement this for themselves. So hopefully this is giving people some food for thought on how to do that, because it can create friction. It's not a application concern, it's a platform concern. In fact, actually Service Mesh touches network, security, application, and platform concerns. So all together, and although its flexibility is there to offer you things so you don't implement them, you just need to make sure that you have the right information from the right people to do that.
Yeah, I like you know, I like this, and my terse summary is, you know, Service Mesh has a lot of features and functionality and capabilities, but it's not quote unquote free, right? There's an operational cost that's associated with it, of having, you know, all of these people be aware of not just how to use it, but the implications of doing so. And the implications can be in many different areas, not the least of which is, you know, maybe some additional complexity at the lower layers, and how to troubleshoot that, how to, you know, fully operationalize and support that. In addition to some real world things like, or when I think the last time you were on the stream talking about this, we talked about, I want to say like 3 milliseconds of latency, you know, that type of stuff get added in there. So I really appreciate this segment.
Thank you. All right, so yeah, some demo time. So we've got a demo which we prepared. It's basically based on a workshop, and the workshop is also it stems from the actual the ebook that we talked about. And there's a link there, and this link basically gets you to a GitHub repository under the Red Hat developer demos. And that will allow you to go through the workshop as a single user, doing all the things from capturing the requirements, obviously for this fictitious use case, to deploying those corporate personal responsibilities and permissions in the OpenShift, delivering a development environment, utilizing the observability stack, and going all the way to production setup for that use case. And here there's a number of modules that we say you go through. So module 6, actually, it's in the actual GitHub is 3 modules. You end up actually looking at performance tuning and troubleshooting in production. So modules 1 to 5 is getting you to go to production with different considerations, such as, you know, having a stable environment in production where if things go down, you don't lose your traces, so persistence. Also, the policies around the authorization policies of, you know, which microservice can talk to which microservice. It also splits, I think maybe it's on the next slide, so maybe actually going ahead of what we have in the slides. It actually consists of splitting, like in a real situation, into 2 domains. So the same service mesh, but actually there's 2 teams that they are operating on it, which is not uncommon, you know. And usually when we started this, we used to say, you know, there's one team and they're responsible for the data plane. There's another team that's responsible for the platform. The reality is not like this, you know. The data plane, all the business applications are split amongst many teams. So here, this workshop considers the fact that you might not be in the same team. So what permissions do you have? What responsibilities do you have? So you can describe that, Ortwin, or do you want to carry on?
Yeah, basically, this is a fictive travel agency company, right? So we have some travel portals here, which is basically you can book travels, right? So the right side, the travel services domain, there's a central travels API we have some other microservice where you can book flights, hotels, cars. So there's one team with different roles managing the travel services domain. There's one team also with different roles for the travel shop domain. And so the requirement is like, we have some requirements here, like for example, we wanted, or this company wanted to introduce really a secure service-to-service communication. We want to monitor the usage and the health of inter-service communications. We want the teams to work in isolation, so we want to also implement with OpenShift RBAC, you know, the different roles, so that when a certain role logs into Kiali or you know, OpenShift only sees their domain and is not allowed to apply certain, configuration of Istio and all of that. And we have some sample requirements here, like, for example, we want to collect 5% of all traces, and we want to save them for 7 days. And so this is kind of outlined also in the book. So this is kind of principles and objectives in this scenario. And basically, Stelios, you can show how this looks in reality if we have time at all. I don't know.
I'm not sure. I'll be honest. I think it's maybe nicer to talk about the day two operations because well, actually, I can show this depending on what Jonny and Sally think. Do we have time? It's maybe 3 minutes before we.
So we work on your calendar, and it looks like it's pretty dark there. So we don't.
I
don't want to keep you up, past your bedtime or anything.
No, it's fine. It's fine. So let me see if I can share my screen. All right, I think.
And while you're doing that, I just want to call out, like, I think that demo is awesome, right? Because you're teaching people how to think about what they're incorporating, right? Like you're showing people like, hey, look, if you want to do this, here's the things that you need to think about, and here's how you can think about it, and take that knowledge in and then apply it. So I as soon as I saw that, I was like, oh man, I love that a lot. That's awesome.
Oh, thank you. Well, the idea was that there's a lot of information out there. The difficulty is having opinionated view, and so on how to set this up. And we use obviously our experience from different use cases. It's not the only way. That's also clear as well. It should be clear to people. But it tries to go beyond the basic stuff and try to showcase and said in the ebook and here in the presentation we talk also about tuning and troubleshooting, which is very important. If something will always go wrong, so you need to know how to look into it when you're using service mesh. So yeah. So what I'm going to show here is basically I'm going to start with Kiali because we saw the static view, and so we've also got some. Sorry, by the way, you can see my screen, right? I'm not just talking and people can't see. Is it shared?
Oh, you're good to go. You can see it.
Yeah, might need to be a little bigger, but
okay. So I will try to increase the font. Is that better?
Yeah.
All right, cool. So this is Kiali, and this is part of the observability stack. And in this workshop, we have two Kialis, let's say, one for the development and one for the production environment. And if I remember correctly, this is for the development environment. And effectively, I've logged in as this person, Emma, and Emma is the mesh operator. So as the mesh operator, actually, she has the capability to look at both the control plane and the data plane. She's actually got the visibility of all the namespaces, and in the Kiali, I've actually selected all of them. I can actually deselect them, and then I'll get nothing here. I might be interested only in the dev portal, in which case I would look at microservices that are in the dev portal, these three, and they can communicate with something in the travel agency, so I can maybe minimize the visibility here if I wanted to look at something specific. But effectively, yeah, let's say Emma wanted to see absolutely everything, so she's got all the namespaces. And effectively, you have obviously the visualization here, but you can change here things on the visualization. So I can maybe look at the response times. So, what is the response time for each of the microservices? Or I might want to see throughput, how many transactions I have. You can also, I think, if I remember correctly, you can, if you just fancy that, you can even kind of get an animation of the traffic flowing from microservice to microservice. So you have a number of things visually to understand very quickly. Is there a problem? Now you can also reduce the time of how often this diagram gets refreshed. It's important to understand that the metrics and the traces that it's captured by the sidecar is what's creating this. Okay, so we can look at every 10 seconds a refresh of the latest traces of the latest metrics in a visual manner. But beyond that, then you can also go a little bit more and look at the Istio configurations. Now I'm just going to take out the Istio system. Istio system basically is the control plane namespace, and the other three are the data plane. This is where our microservices and their sidecars are deployed. And you can see here also what configurations you have applied. So you can see in my service mesh, maybe these three namespaces are specific for the solution of the travel agency. Maybe my service mesh has other namespaces as well. But if I wanted to just look at these three namespaces, then I can see, what are my Istio configurations, what are the services that they are part of it. Okay, I can look at my workloads. Now I'm the operator, so I can see many things. So if I go here, I can see the logs and everything else. However, like we said, in this particular situation, we have two teams, the agency team and the portal team. And so these two teams deliver both configurations and microservices in the different namespaces. So if I take a different role, okay, so if I log out and say, if I remember correctly now the roles, we have Christina, who I believe is the portal domain owner. And here, as you can see, we can see the microservices from the portal, but we can't see the microservices from the travel agency. So this is the application domain owner who delivers configurations and for the service mesh for this particular part of the solution. And although they can see that my solution is talking to something else, it's important to know the inter and intra integrations with other things. I can't see here things around the logs. I can't see the configurations, and I can't actually manage them either. Right. So if I was to go through the Istio config to modify them, I can only modify what's in my domain, in my namespace. And this is applied based on the roles and responsibilities we identified earlier and the permissions we've applied for that group to only be able to apply and do things for those namespaces. So in that case, I can go in and I can okay, let me see. Can I see the traces? So, okay, maybe I've chosen the wrong row. Why is that? Okay, let's see the travels and the logs. Okay, so maybe I'm not actually able to see in the control namespace, but I can see in the portal namespace because my team is responsible for delivering these configurations. So you also reduce the sensitivity of who can access what they can see with Kiali. So that's the overview. And now let me actually see if I can, and I apologize because I don't remember now the password. So you can see my password, but it's okay because it's only short-term environment. Hopefully I can log in. So let's see also what's on the control plane, because this was about the data plane. So in the control plane, this is the production environment. As we talked about earlier, we can have a number of different things. We can have the egress gateways, and we've deployed here the control plane with 2 egress gateways for production. So that means we have high availability if one disappears, and the same for the ingress gateway. We've also got 2 Istio services. What does the Istio service do? Is maintaining up-to-date configurations for the sidecar proxies, the ones that basically intercept the traffic in and out of your microservice in the mesh, and also apply updates to the certificates used for MTLS. So basically maintains the whole of the data plane up to date with the latest configurations. And so you don't have to go, if you used to have certificates applied in your application, you don't have to do that in your application. The Istio service will do that. If you used to do traffic configurations or resilience configurations with some libraries in your microservices, you don't have to do that. The Istio service will look at the configuration applied and apply them in the right sidecar proxy. And actually, I'm going to go back here because one of the important things I forgot to mention is that you can see the Envoy configurations here on the Kiali. So this is a list of all the configurations, and hence why I was talking about that it can get very big once you have many microservices as part of the mesh. But you can see effectively the clusters, so the destinations that you can set traffic to in the mesh. You can see different listeners that you expose. You can see routes configurations through virtual services applied, and you can also look in very detail the overall configuration. So this is basically what the ECUD will inject in each of the sidecars, so they know how to communicate with each other. They know what are the limits, if there are limits, what are the security configurations, and that's done through the ECUD. And hence, the more microservices you have in the data plane, you need to manage maybe the overall service mesh with more ECUDs in order to have a performant control plane. Prometheus, obviously, it's for metrics capturing. Grafana for visualizing some dashboards. I can actually look at this now. So here in the Grafana. Okay, I'm going to log in. It's fine. I think I'm going to log in as this person. So there is the deployment of the service mesh results in the in making available some standard dashboards. So here very quickly we can actually I'm going to choose a different one because this is for the control plane. I'm going to choose this one. So here, for instance, I can see very quickly all the microservices that are part of that service mesh. I can see also the success rates of the traffic. So very quickly I can visualize is everything healthy, are things not going so great, but then I can also look at performance information. So the CPU used in the and also based on the component version as well. I can also look at the more specific information for my services, right? So I can look at operations for that microservice. I can also look, the client workloads, incoming request, or the size of the. So more and more details can be extracted from the Grafana based on the metrics that is being captured. And so I think these are the main components. Now you will see here that we also have got RHSSO. We've deployed RHSSO is not part of the default deployment in order to apply authorization policies and integrate that with our ingress gateways in order to offer the capability for the application teams to define authorization policies. But pretty much that's it. Now, one thing I didn't show you is basically the operator. So Ortwin mentioned earlier that we utilize the Red Hat OpenShift service mesh operator. So we have the product is based on Istio. We've implemented an operator to make it easier to deploy the service mesh and its capabilities through an operator. And this operator can be combined with Kiali operator, OpenShift Elasticsearch operator, and the distributed tracing operator to deliver the Jaeger, the Prometheus, the Kiali components of the overall service mesh, but without having to implement this ourselves. We rely on the other operators themselves. So this is the operator, and this is the control plane that Ortwin mentioned earlier. So you can, as you can see here in my cluster, I've got 3 different control planes. So I'm utilizing a multi-tenant cluster. And in this multi-tenant cluster, I have segregated the configurations and the traffic in 3 different distinct areas. So I have user 1, because it's a multi-tenant, the dev environment, and user 1 production. So I've set up a dev environment and a production environment for this solution, whilst the user 2 is currently only having a development environment. And the control plane output, whether you have 1 ingress gateway, 2 ingress gateways, whether you have persistence in your Jaeger and the likes, is defined based on the service mesh control plane CRD, and the operator will deliver the relevant deployments for the service mesh and the relevant configurations. So that's the workshop. That's what you end up working on. Now, there are, as I said, many areas of it. So we go through also how you can change. So we talked about MTLS. So we go through how you can change the MTLS certificate in your control plane, so that control plane components can utilize a corporate or intermediate corporate certificate, and the same thing for the data plane in order to produce the certificates that they used in the communication service and encrypt that communication end to end. So by default, it utilizes a default certificate, but in the workshop we go through this. I don't know what else I can, and there's so many things I could show on this. So let's see. Yeah, so maybe I'll just go through the production walkthrough a little bit. So as I mentioned earlier, in the production setup, we have a Jaeger installation. This is a separate operator managing the Jaeger. We utilize Elasticsearch for supporting, based on these requirements that Ortwin showed earlier, 7 days backup of the traces. So if things go wrong and the Jaeger instance disappears, we're not losing our traces. We basically have a backup of it. And we utilize that Jaeger effectively within the service mesh control plane, where we sample, well, in this case, I think we start with 20%. Eventually, we reduce that to 5%. We also utilize something called the outbound policies. So the service mesh not only isolates the traffic for incoming requests, but also it can isolate for external requests. That means if you do not want the application teams to end up going to the wrong database or to the wrong APIs, you can set them to only allow what's registered in the mesh to be allowed as an outbound policy. And that means you need to define effectively traffic configurations in the service mesh through virtual service and destination rules, which would allow you to come out of the mesh and go to the database. And that can then be applied based on the policy, who's allowed to define these network configurations. So that's another thing that you can do with a mesh. I think that's pretty much, I mean, there's more stuff, but effectively, yes, you can set up a production environment with all these components. Now, I'm going to go back quickly to the presentation. So if I can go to this section for a minute. Hold on a minute. Where is it? It's here, I think. Yes. All right. So couple of final things I want to talk about the production environment and what you can do with it. And this is part, as it says there, part of the chapter 8 of the tuning the service mesh on inbook. It's important to be aware of what you can and should monitor. There's many things, there's many metrics that you can monitor. But if I was to give a very quick suggestion to people on what you can monitor on the data plane, there's a couple of metrics. Istio request total basically means you look at the number of requests that come in, and I just realized I've copy pasted the wrong metric for the latency. I'll find this and change it in the final presentation. And there's another metric for the latency. So these two metrics gives you very quickly an understanding. If I put my solution in the service mesh, do I get the same number of requests as I would without? So you can kind of compare and contrast. And the same thing for the latency. Do I get a very bad latency? Do I need to tune against that latency? Is that acceptable? And for the control plane side, which manages, as I said, the configurations in the data plane side, there's the pilot XDS, which shows you how many components on the data plane are connected to that IstioD that manages their configuration. So obviously, as you increase the data plane side, that number will increase. And then the pilot proxy convergence time, it actually shows you how long does the IstioD take in order to update the sidecars on the data plane, and that shouldn't be more than a few milliseconds. And if you see that to be increased, so that's another thing you can apply on the Prometheus, and you can create an alert with it. If you see that actually that convergence time increasing, then you might need to make some suggestions. Do I need to tune the ESTD? Do I need to increase the instances of the ESTD? Do I perhaps have a service mesh that manages too many components, and maybe the right approach is to separate it out to different service meshes or to different clusters? Okay, so that's my maybe 2-minute advice about how you can start about tuning it. But the links on this slide will actually get you to the ebook and also to the GitHub repository behind it, where we have a lot more examples of how we tuned that use case. And then I'll close from my side with the 10 questions for mesh troubleshooting. It's a nice round number. So you probably need to look at things when things go wrong. You need to look at least these first 10 things. Is the Istio network configuration syntactically valid? And you can see that actually straight away in Kiali, right? You can see that there's a configuration that is wrong here. There's like an icon on the right-hand side, that red thing that says something is wrong. And you can kind of see, okay, maybe that's something wrong with my syntax there. And also, does the network configuration have an error or a warning status set? Is the resource the right name? Many times we've seen the configurations being slightly wrong, which meant the service mesh did not, applied them, but had no way to understand that this configuration should not have been applied. So you need to make sure that these configurations are correct, the resources are correct, the labels are correct, the selectors. And then did the envoy accept the configuration? So you can utilize a tool called Istio-CTL Analyze, and it will actually give you an understanding of if there's any warnings, if the envoy has accepted, and so on. So, and finally, I think I've got also here another one to kind of show you about whether it's been accepted or not. And you can see here that something was not sent. So the Istio-CTL tool actually helps you there. There's other things as well, but if you start from these 10 things, at least you'll be able to make a good start in troubleshooting the problems. I think I'll stop around the workshop here. Do you want to take over, maybe talk a little bit about the roadmap and close that, Ortwin?
Yeah, sure. So, Stelios, great to see your passion around service mesh again and again. And so now after the let's say 10 commandments, or how do you say that in English? Yeah, is that right?
Yeah.
Okay. Let us finish fast and strong with the roadmap. I think this is also quite an interesting topic as well. Let me also share my screen again, and we'll have a look at the roadmap section. So service mesh roadmap, we're currently at 2.4, so which is based on Istio 116 and Kiali 165. And what we have right now, or a new feature, is a cluster-wide installation option. So this is like what Istio upstream is kind of by default. So the default in OpenShift is, I think it's still multi-tenant, but you have now the option to install it cluster-wide. Also, if you, for example, have one large mesh with a lot of different namespaces, it will definitely increase the performance and reduce all the amount of API traffic calls and things like this. Then, as mentioned, there's the integration with Cert Manager right now. There is an external authorization with auth policies. Also, Kube Gateway API is still in tech preview. We're working on this as well. And the interesting part is what's coming next. There will be one release, 2.5, and after it, we will go to OpenShift Service Mesh 3, and a lot of things will change there. So we're working on Service Mesh 3, and we want to really converge Service Mesh with Community Istio. So we want to productize kind of upstream Istio, and we do not bundle it like we have it right now based on the Maestra project, with Kiali and Jaeger and so on. So these will be kind of external or let's say modular products that you can use, but the thing is, we want to be closer to upstream Istio. So a lot is happening, and we want to really to bring the latest features enterprise ready also to OpenShift of Istio. This is one of the reasons. So we need to work closer and collaborate closer with the Istio community. So there will be a new operator then, and it will support, the official installation mechanisms from upstream Istio. So there is Helm, there is an Istio operator, and you can use the same mechanisms to install Istio there. By the way, I share a link in a second. There is also, you can test this new operator. So there's a dev preview version of it right now, and you can already test it and provide feedback if you like to. And as mentioned, the new operator is not based on Maestra. So all the things you have right now, so the service mesh control plane, CRDs, member roles, they will not be part of Service Mesh 3. Also mentioned Service Mesh 3 will only manage Istio, and all the other things will be separate operators with their own life cycle. So there's Kiali, there's distributed tracing, and so on. Also, we want to accelerate the support for things like Istio CTL. There's a lot of requirement from our customers right now, because this is the standard Istio CLI. And currently, we don't support this. So this is something we have on the agenda. Then also the canary upgrades, for example, of the control plane, additional topologies like multi-primary, and also ambient mesh in the future. So it's still very early for ambient mesh. Basically, it's a sidecarless version of the data plane where you split like the level 7 and level 4 functionality. And there is more or less one node agent, or you have one node agent, and this one is handling the level 4 traffic. And per application, you will deploy one envoy as a waypoint for level 7 features. So from the user perspective, ambient mesh, there's not that much change, but it can improve the performance a lot. And there's a lot of talking and discussions around ambient mesh as well. So also we will get way closer to productize also this part of Service Mesh. So as mentioned, there is this new developer operator out there. I shared a link with you in just a second, and Service Mesh 2.5 will land in Q4, and it will be the final release on 2.x, definitely. So the last step before we move to Service Mesh 3. This is the roadmap in general. So as mentioned, for Service Mesh 2.5, there is the main thing, I would say, update to Istio 1.18 and GA support of the Gateway API. Also support for ARM architectures. The Service Mesh 3 operator will be in tech preview. Also interesting, Kiali, there's a Kiali plugin for Backstage then in developer preview. So this is our new product, Red Hat Developer Hub. So a central interface for developers where they can, create services based on golden path templates. It's a central point for information, for documentation, for API documentation and all of that. And you can also extend it with certain plugins, so you can look into the real cluster. So for example, you have your microservice, and you can in Developer Hub look at it, and also look in Kiali, like how's the things, the traffic flowing through services. So this will be pretty cool, I think. Then with OpenShift 3.0, as mentioned, there will be the CLI support for Service Mesh, other upgrade mechanisms, ambient mesh as dev preview, and from there we move on. Also,
Ortwin, all I'm hearing is we're going to have to bring you back on in the first half of next year. But
Yeah.
I think so with 2.5. gateway API support, that's a big one. There's some pretty significant things that impact, or that impacts, and how it can be used for ingress and all kinds of other stuff. So that one I think is definitely going to be an interesting topic.
Yeah.
Omar, I see your question here. Are you so can you talk in the future in more detail about certificate management for Mesh? I'm not sure if you're requesting like a topic for the future, or if you mean here on this stream. But Ortwin or Stelios, I don't know if you have anything to add about that.
Yeah, so I mentioned earlier that we do have something in the workshop. Effectively, there are 2 certificates you can consider that you might need. Certificate management within the service mesh. You obviously need for inter-mesh communication through the MTLS capability. And I think I saw in the chat, you can utilize either a question about that. Sorry, that's what I mean in the slide and this on the chat. You can utilize out of the box a secret, which contains the certificate authority, so you can actually provide them the capability to create the certificates for service communication. You can change that to also utilize, I think now, Cert Manager for delivering that. And the other certificate management consideration is for external traffic. So this is in the ingress layer. And for that, again, I think you have Cert Manager that can deliver the secrets, or you can have the secrets as part of your namespace, wherever the ingress gateway is injected, whether that's in the control plane, data plane. So the rotation of the certificates can be a GitOps activity. All right, so meaning that you can deliver them in the right namespaces, either as part of delivering your service mesh control plane, if that's where you deliver your certificates, certainly for the purpose of the service-to-service MTLS communication, or it can be part of your vault with the Cert Manager being, I guess, integrated, so you can actually manage that. There's capabilities for both. It depends on what each team decides to follow. There's flexibility for both. I hope I've answered that to an extent.
All right. Well, thank you. This has been probably one of the most information-dense streams we've had in a long time. This has been super helpful, and I've learned a ton. So
exactly, yeah.
So
we try to not put everything in there because I saw that somebody said that we can make these sessions a bit longer. For this type of topic, unfortunately, it's whatever we put, it wouldn't be long enough. So that's why we put the link there for the workshop, because it will help people to do it in their own pace. That's the only way I would say.
Yeah. Service mesh is one of those things that reinforces my fractal comment about OpenShift and Kubernetes. Like, for every question you answer, there's an unlimited number of new questions that get unlocked, and for every one of those that you answer, there's it just never ends.
Right.
So yeah, this has been a lot of fun. Like I said, I've learned a lot, and I really do appreciate all the different aspects that you all are taking towards this, and I'm definitely looking forward to looking more in depth at the ebook and just continuing to learn more. For the audience, please feel free to ask any questions that you have. Get them in the chat here. You can also reach out. So if you're watching later, if you're not watching us live, or if something comes up after the stream ends, you're also welcome to reach out to us. So you can reach out to Jonny. So let's see, where's my little thing here? So Jonny, you can reach via email via jonny@redhat.com, JONNY@redhat.com, or JRockTX1 across all the various social platforms. You can also reach me via email at andrew.sullivan@redhat.com. Super hard to remember. Or at Practical Andrew on whichever one of the social media platforms you happen to be on. If you were watching chat, I replied to I think our Hope 9, and my handle popped up on there from Twitch. So yeah, you're welcome to reach out to us. Jonny and I are on all the various places, including LinkedIn and Reddit and Slack. So I generally encourage folks to go to the Kubernetes Slack. So we'll put that link up there. So if you go to kubernetes.slack.com, if you don't want to remember that, C6 Alpha Delta 6 Juliet Mike 17, man, I can't believe I remember the phonetic alphabet. It's been a minute. If you don't want to remember that, you can just go onto the Kubernetes Slack, kubernetes.slack.com, search for the OpenShift users channel. And that's where you'll find most of us. So with that being said, thank you, Ortwin, Stelios. This has been just absolutely phenomenal. I've learned a tremendous amount.
Yeah.
So I'm definitely looking forward to having y'all back and talking more about Service Mesh. So
thank you for having us. It was definitely fun again being here.
Yeah. It this is one of those things where, like I said, it's hugely, I'll say, feature packed. There's tons of stuff that can happen or that it's capable of doing. And I'm blown away at one, throughout this thing, y'all have reminded us that you don't have to use everything, right? It's okay to only use the parts that you need. And you actually need to take that into consideration, because if you try and implement everything and you don't need 80% of it, you're not going to be happy. And, that's an important thing to remember.
But it shows really the potential of OpenShift, right? So you don't only have the platform itself. So just one of the layered products we've discussed just briefly today can give you so much value, can extend, the capabilities in general a lot, right?
Yeah.
So there's a lot of potential, and it's optional. You don't have to use everything. So yeah.
Yep. And I see the question there about next week's topic. Next week, we're going to have, who's coming on? Chris Porter, I think.
Chris Porter, yep.
Yeah, from the ACS team, to talk about vulnerability management with ACS and managing that with images and all that other stuff. So, Savion, please join us if you're interested in all that. We're kicking off DevSecOps month next week, leading up into KubeCon. All right, y'all. That's all I got. So if anything comes up, if you think of anything, don't hesitate to reach out to us. And Jonny, I'll leave you with last words.
Yeah, just wanted to quickly say thank you to the audience for sticking with us for an hour and 45 minutes. That's really awesome. So really happy to see that y'all did that. Love all the questions and all the interaction. Right? Again, Andrew and I feed off this stuff all the time, and hopefully Ortwin and Stelios also get to feed off some of that energy, because we love answering questions. That's what we do it for. And guys, thank you so much for doing this. I really do appreciate it. And I love your approach on the lab. You're not just leading the horse to water at this point, right? You're leading the horse to water. You're kind of showing them how to drink it. You're giving them different ways to drink the water and how to do things with it. So I really like the approach, and it's kind of a different take on like the thought leadership part, right? Where you're trying to enable people to do things. So I think it's a really fantastic way of doing it. So good job, excellent work, and hopefully we get you guys back on here.
Thank you both.
Thank you.
All right.